Chapter 5, Section 2 is going to be about solving inequalities with multiplication and division. In the previous section, Section 1, we talked about solving inequalities with addition and subtraction. So you kind of are getting the feel for how these are going to work using addition and subtraction to solve them. We're still going to be doing that, but instead our main focus in this section is just going to be using multiplication and division. So still doing like one-step type equations here. You might still see a little bit of the multi-step equations where you're having to add or subtract first and then multiply or divide. So we'll see kind of a combination of all those things in this section. Graphing on the number line is still going to happen in this section, and the rules still apply like they did in section 1, where you've got open circles if it does not include the equal sign, and closed circles if it does have the equal sign. Just like before when we talked about addition and subtraction properties, we have the same properties that apply to multiplication and division for these inequalities, which basically says whatever you do to one side, you have to do to the other side. You got to keep this balanced, just like we did with those regular equations that involved an equal sign. So I'm going to go ahead and jump into just an example that you're going to see dealing with a multi-step problem. So dealing with like addition, subtraction, kind of including those steps first before we get to the multiplication and division. So for this first one, I've got 3x minus 16 is greater than or equal to 23. So what I want to do first is add 16 over to the other side. Remember when you were solving an equation that you always wanted to move the regular number piece first before you dealt with the term that has the letter. So we're going to have 3x greater than or equal to 23 plus 16 would be 39. Then I need to get that 3 by itself, so I'm going to divide both sides by a 3. So we have x greater than or equal to 13. So there's your answer. And then just like in section 1, we need to put this on a number line. So 0 is going to go on the left-hand side. 13 is going to go on the right-hand side. We're going to have closed circle around the 13 because my inequality does have an equal sign and it's pointing to the right, so I'm going to shade to the right because it's greater than 13. So there are a couple of practice problems that deal with these same type of problems, multi-step type equations here. Go ahead and try to do both of those examples. If you're watching this video, I want you to pause it. Try to do these two problems and then resume watching when you're ready to see what they should have looked like so that you can see if you did them right, and if you didn't do them right, you can fix them so that they're correct for your packet. So for this first one, I'm going to subtract 6. So I have 5x is less than 35. Then we divide by 5. So I have x is less than 7. So on my number line, 0 goes on the left, 7 on the right. This time you should have an open circle because there's no equal sign in our inequality, and we want to shade to the left. For the next practice problem, you should have started by adding 8. So we have 3x is greater than 27. Divide by 3. So I'm going to bring this over here. We've got x is greater than 9. Zero on the left, 9 on the right. Open circle around your 9, and it says x is greater than 9, pointing to the right. So we need to shade to the right. Okay, when you take a look at this next chart here, it might look like it's going to say the same thing as it did on the front page of your packet here, but this is talking about something slightly different. because you're talking specifically about if you have to deal with a negative letter. So if you remember in section 1, I said to keep your variable positive. So do not move it so that you would get a negative letter, because at the time I really did not want to get into too much detail about what happens if you're dealing with a negative letter, okay? But now that we've been practicing these inequalities, it's time to get into that situation where what do you do if you have a negative letter? Because there are going to be situations where it's unavoidable. Like you cannot do this problem without dealing with a negative variable. When you're dealing with problems that have a negative letter, a negative variable in your problem, you can't leave it negative. So if you end up with like negative x is less than 10, you can't leave your problem there. We always need the letter to be positive. So now we're going to kind of open up that door to what do we do with our problem if we're dealing with a negative. It requires you to make one minor change. It's not a big deal. All you have to remember to do when you're dealing with a negative letter is when you're dividing both sides by like a -1 to make that letter become positive, is you're going to have to switch your inequality sign. So what do I mean by this? If I have a problem like this one that says -5x is greater than 60, I'm going to divide both sides here by that -5 because I need to get x alone. Okay? I have my x now, and I'm going to take 60 divided by -5, which would be -12. But here's what they say over here. Division by negative flips the inequality sign. So because it starts as greater than, when I divide by a negative, I have to flip this sign around so it becomes less than. So it looks like that. X is less than -12. Now, for these last couple of problems, I'm not going to focus on graphing on a number line. We've practiced that enough. I think at this point, we're going to kind of just solve them. And if they ask for a number line on like a homework problem or maybe like on a test or an accountability check, then I would want to see you still do that number line. If the problem doesn't specify for a number line, then I wouldn't worry too much about it. Okay, so this one is x is less than -12. Now, if you take a look at this next one, I've got this variable -x over 4 greater than or equal to -2. Remember, when you're dealing with a negative in a fraction, it really doesn't matter where it's at. So like they could have written this as, like they did, -x over 4, or they could have said x over -4, or they could have put the negative out front. So it really doesn't matter where the negative sign is. The point of this problem is that I got to get rid of it. I got to get my x to be positive. So what I'm going to do is multiply both sides by the 4, because I want to get rid of the fraction. So I'm thinking about like multiplying by its reciprocal. But I also need to get rid of that negative. So I'm actually going to multiply both sides by a -4. When I do that over here on the left, that's how I finally get x by itself. And now it's positive. I got to switch my inequality sign. So instead of saying greater than or equal to, it needs to switch to less than or equal to. And then I'm going to take -2 times -4, which would be 8. On the bottom of this page are 2 practice problems for you guys to try what I just showed you. So pause the video, take a minute, do these problems on your own, and then resume watching the video. For this first one, I would have divided both sides by -6. So I have x, switch your inequality sign, greater than or equal to -9. For the second one, we're going to multiply by -3. So I have x is less than -12.